Warm greetings, everyone. My dear children, my dear students. So we'll start up the new class with some positive quotes. Okay. So this is the quote. It was given by Zig Ziglar. His name is: "You don't have to be great to start, but you have to start to be a great." Okay. So let me repeat. You don't have to be great to start, but you have to start to be great. Okay. So, actually speaking, learning is never done without errors and defeat. Okay. So, failure isn't final. In fact, it can be a powerful tool for growth and progress. This is very important. Failure isn't final. Okay. You have to take that as a powerful tool for your growth and progress. This is very important. With this quote, we'll get into the video, video lesson. So today's topic is oscillations. We are going to see oscillations today. So there are different kinds of motions, various kinds of motions you have come across, you have already learned. But few examples we are going to see. So maximum, you must know about what is meant by rectilinear motion. This is very important. So this one, it talks about rectilinear motion. Okay. So this is rectilinear. Okay. So what is the rectilinear motion? Do you have any idea, students? Okay. So let me explain you. So all particles motion is now recorded. Okay. So you have learned so many types of varieties of motions. So what is meant by rectilinear motion? If you are considering x-axis and y-axis, if a particle starts moving, for example, this x will be the time axis, this y will be the displacement axis you can take. Okay. The particle is started moving. From 0 second, it started moving. After 5 seconds, it will be here in this point. Okay. Let this be, for example, 5 centimeter. Okay. So I always used to quote the lizard's movement to our children actually, because I'm really scary about all the lizards. So the lizard's movement, you might have seen it. It might moves in a random manner. It might moves to catch all the insects and all. So that is their focus. That lizard's focus, right? So you might seen that in a on a wall. The wall is example for 2D motions. That is x and y plane. Okay, if a lizard started moving, so after 5 seconds, it will be its movement will be 5 centimeter. Then after 10 seconds, you might have seen it crosses 12 centimeter, for example. So after 15 seconds, it crosses actually 30 centimeter. For example, I'm saying. Okay, so this is the movement of a lizard. Okay, lizard is also a macroscopic particle. Like way, microscopic particle also moves. Atoms, molecules, electrons, everything is moving. So for this movement, we can say this is the rectilinear motion. So it forms a rectangle, right? So this is said to be the rectilinear motion. This is the famous example for like rectilinear motion. If you want to know about that, you can take it as a screenshot and save it in your pages. Okay. So this is and motion of a projectile. Also, you have come across what is the motion of a projectile. You know that if a stone is thrown from ground, then it traces a path of a projectile. Okay, that is the parabolic path. Okay. So it moves to the maximum height and then it reaches the ground. It hits the ground at maximum range. This is said to be maximum range. These and all you have come across. Now we are going to talk about uh, actually the oscillations. What is an oscillatory motion? So the periodic to and fro motion, that is an oscillatory motion. If a particle is moving to and fro like this, if it is periodically moving, then it is oscillatory motion. Then left and right also, like this also. Okay. So all periodic to and fro or left and right, whatever it might be, that is said to be a oscillation. Even a vibrating string also produces an oscillation. So sound waves or the particle movement or the vibration, whatever it might be. So that is recorded as a oscillations. Okay, so here you might have come across all oscillations. Okay, so what is the equation of motion involved in this? This is very important topic, very important concept you must know. You know all the three equations of motion. What are the three equations of motion? S is equal to ut plus half at square. First one is v is equal to u plus at. This is second equation. Third one is v square is equal to u square plus 2as. Right. So here S is the displacement, u is the initial velocity of a particle, v is the final velocity of a particle, a is an acceleration, t is the time period. So everything you know. So by understanding suppose here one example is given. What is this? 14.1. So first one, what is an example? Suppose, so as I've told you, no, the same. Here they are quoting insect. So I've quoted blizzard. So here insect. It climbs up a ramp and falls down. Okay. It comes back to the initial point and repeats the process identically. If you draw a graph of it, of its height above the ground versus time. So always keep in your mind this oscillatory motions based on time period only. Okay, it is relevant to time period. So you have to always take time period in a particular x-axis. Always, all the motions, all rectilinear motions we are talking about. So that is the time period on the x-axis. It's motion or displacement on the y-axis. Got the point? Okay. So if a child climbs up a step, this is, for example, the first example is given like that. Here the child is climbing up a step. Okay, and then comes down and then repeats the process identically. Okay, its height above the ground would be look like in a figure it is given. Okay, so like this it is doing the repeated motion. Okay, the child is climbing. Then when you play the game of bouncing a ball off the ground, so you are playing a game, so the ball's bouncing. Okay, so its height versus time graph is given in where? No, the height above the ground will be given in the picture 2. Okay, this is the height above the ground. It is given here. In picture 3 only, you might have seen the bouncing of a ball. This is the bouncing of a ball. Okay, so here, okay, so it is given like that. Between your palm and the ground, its height versus time graph would like this. Okay, now both the curved parts in figure 4.14 both the curved parts you might have seen. Okay, so are sections of a parabola. So how the parabola will be? It is a curve. Okay, it might be the section of a parabola. Okay, and by it is given by the Newton's equation of motion. So you know that we can take the displacement means displacement is equal to ut plus half at square for downward motion and minus half, against gravity it is minus g. So minus half gt square for upward motion. So these are examples for periodic motion. It repeats in equal intervals of time. Okay, this is very great example given in your book. Then so many lot of stories are given. It is very easy to understand. You just go through it. Then oscillations and vibrations are given over here. And then period and frequency. You must understand what is the period, the smallest interval of time. Okay, after which the motion is repeated. The smallest interval of time after which the motion is repeated is known as the period. Okay, the period is always denoted by capital T in your book. Okay, and the small t is the time axis, that is x-axis. So frequency also you must understand what is the frequency, the number of oscillations like this, the number of vibrations per second. So per second means you are concluding the time period. You know, the period of a wave will be one complete oscillation. So one complete vibration. That is the period of a wave. Okay. Period of a vibration. Here we are talking about, we are fixing, we are determining the time period as 1 second. Within 1 second, how many waves are traveling? So that is said to be the frequency. Because if it is a subatomic particles, when you consider in the vibration of an atom, vibration of an electron, it is really, really high when compared to the normal macroscopic particles frequency. So in 1 second, you might have experienced 6,000 that electron waves, that electron vibrates in 6,000 waves or 60,000 waves or 6 lakh waves or trillions of waves in 1 second. It can be able to make. Okay. So the macroscopic particle only make, it can make one wave or two wave or something. Okay. So like it is varying. So we are determining a parameter as a 1 second, time parameter as a 1 second. Within 1 second, how many waves are repeated? How many waves are there? So that is said to be the frequency. So frequency is always denoted by 1 by time period. That's very important. Not total time, it's the time period. So it is denoted by hertz. Sorry, its unit is hertz. So after the name of Heinrich Hertz, Heinrich Rudolf Hertz. His period is 1857 to 1894. So he only derived this unit. Hertz is the very, very big unit. And then 1 hertz equal to 1 oscillation per second. This is very important. You should keep in your mind. So its unit will be second inverse. Okay. So this example also says actually in a human heart, an average okay, human heart is found to beat average 75 times in a minute. They're asked to find its frequency and time period. So the beat frequency of a heart will be 75 per 1 minute. Got to convert into seconds. So that is 1 minute can be converted into 60 seconds. I mean, divided by 60 seconds, it will be giving you 1.25 second inverse. That is hertz. Okay. And then what is the time period? You know that time frequency is 1 by time period. What is time period? 1 by frequency. So this is the letter which is known as nu, which is denoting the frequency. In some book, you'll be given F frequency. Okay. So 1 by 1.25 will be zero point 0.8 second. What the point? Okay. Then you must know about the displacement also. If you are considering, for example, in case of rectilinear motion of a steel ball on a surface, the distance from the starting point as a function of time is its position displacement. Okay. So its distance, we have seen that rectilinear motion, right? Like this. The distance from the starting point with respect to the time axis. So that is its that as a function of time period, if you are taking as a function of time period, that is known as position displacement. Okay, the choice of origin is a matter of convenience. It might be start from 0 comma 0, or it might be start from here, or it might be start from here. So that is different. Okay. And then consider a block attached to a spring. The other end of the spring is fixed to a rigid wall. Generally, it is convenient to measure the displacement of the body from its equilibrium position. For an oscillating simple pendulum, yeah. So these two pictures are given here. Okay. So this is the spring. Okay. A block which is attached to a spring. The other end of the block is, I mean, other end of the spring is fixed to a rigid wall. The block is started moving on a frictionless surface. So this is actually a frictionless surface. So it gets started from this place to this place. So it takes up a displacement. This is linear displacement, Ex. The spring which is attached to a block at one end and one end, it is fixed. If it started moving, if the block is started moving, then it gets displaced linearly by X. Okay, from its equilibrium position. So you have to see to that. Suppose if you are considering a bob of a simple pendulum, it moves, it oscillates right side, then comes to mean position, then left side, then comes to mean position. This is recorded as one period or one oscillation. Okay. Then, so it can be described by its displacement can be described angularly, and then it is denoted by theta. Okay. So all can be recorded as a function of time period. So what is the function of a time period? How can we take this? So everything comes under the simplest periodic functions a cos omega t. So we are considering the displacement variables like this. In this, so let me explain you about all these things in the later portions. So there only we are going to learn about sinusoidal waves. You know that a sine wave and cos wave. So mathematically, you must understand what is sine wave and what is cos wave. This is the time period. If you want to plot a sine wave, okay. So what is sine zero? Sine zero will be zero. Okay, this is y displacement. If you think of its maximum value, its maximum value is plus 1, its minimum value is minus 1, right? So now it started climbing. I mean, if you are having the value of sine 0, that is also 0. Then what about the sine 180? Sorry, sine pi by 2 we can take. What is sine pi by 2? Sine pi by 2 is the maximum. Okay, what is sine pi actually? So sine pi, again it becomes 0. Then what is sine 3 pi by 2? So it becomes negative 1. Then what is sine 2 pi? That will be positive 1. Sorry, 0 again. Then what is 5 pi by 2? Okay, that is positive 1. Like that it will be. So if you traces this path, it will be like this. Okay, it is said to be a sinusoidal waveform. If you consider cos, then how the cos will be? Cos 0 is 1. That the value of cos also lies between plus 1 and minus 1. Cos 0 starts from 1. Okay. And then pi by 2 will be cos pi by 2 will be 0. Then cos pi will be minus 1. Minus 1. Okay. So 1, 0. Then cos 3 pi by 2 will be 0 again. Then cos 2 pi plus 1. Then 5 pi by 2, 0. Like a way it travels. So there is a phase difference between the sine wave and the cos wave. This is the cos wave. Um, this is sine wave. Here the argument will be omega t it is given. Okay. Where omega t is the argument. Argument means theta. Theta is taken as omega into t. What is theta? Theta is the displacement kind. Okay. How it comes? You have to put cos theta, right? Okay. So A is the amplitude. Amplitude means thickness of a wave. I mean height of a wave or width of a wave. That is amplitude. Okay. How the waveform is described in a function of time period. So that is what I'm explaining. And then cos theta has to be there, but we are taking theta as omega t. How it comes? So theta is the displacement. Okay. And then omega is the angular velocity. Okay, easily you can connect, my dear children. So this is very simple actually. Physics are very simple. And then you can be able to understand this concept in a clear manner like this only. You have to follow this. So it is angular velocity and then time period. What is the famous relation? Distance equal to speed times time. Right. So here also displacement is equal to angular velocity times time. Okay. It justifies. So we can replace theta as omega t. Okay. So you know that it might be increased in 2 pi, right? Suppose if we are talking about 2 pi, every 2 pi's it has the waveform. For every 2 pi's, it is repeating. So 1, 2 pi's again, if it comes around 4 pi, the same wave is repeating. So until this, you can see everything. Okay? Until 2 pi. Got the point? Then the value of the function remains the same. The function f of t is then periodic and it's periodic t. Okay, and the period t is given. T can be written as, what is this? This time period is frequency 1 by frequency. The frequency will be 2 pi by omega. So what is this? 2 pi is the distance we talk about. Omega is the frequency. That means angular velocity. The angular velocity can also be written as omega can also be written as 2 pi nu. Okay. So 2 pi by 2 pi nu. So 2 pi gets cancelled. So how the angular velocity can be taken into account? We saw this wave function, right? This wave function can also be written as a circular form. Okay. How we can written as a circular form? Plus 1, minus 1, like that. Okay. So if you are taking a sinusoidal waveform as the maximum, minimum, plus, minus, 0, okay, minus 1, plus 1, 0, like that. So here in this, what is the angular, uh, I mean, displacement? Angular displacement will be 2 pi. Okay, here also, right? 2 pi. The angular displacement will be 2 pi, and then 2 pi is the distance or displacement we can take. So distance or displacement by velocity. So distance by velocity will be the time taken. So the time taken as distance by velocity. So here angular displacement 2 pi by angular velocity omega. Angular velocity omega can be equivalent to 2 pi nu. So 2 pi gets cancelled. So you'll be having 1 by nu. So this is also justifying. Okay. Now we are going to talk about the function f of t is periodic with period t. Okay. So we are taking f of t as f of t plus capital T. What is f of t here? A sin omega t plus b cos omega t. Okay. So what is a now? Okay, how we can take this? So f of a linear combination of sine and wave functions, cosine functions, or like this. This is the linear combination of sine functions and the cosine functions. You can take the two displacements as a and b. Like a wave only, we can talk about a particle's vibratory movement, a particle's oscillatory movement in terms of sine and cos. So combined, we can take. So as a function, it is a function in sine and cos. Okay. So here A is taken as d cos phi. B is d sine phi. Okay. So how it is arrived? Do copy along with me. So what is f of t here? A sine omega t. Right? So plus b cos omega t. Then f of t is equal to, what is a here? A can be written as d cos phi sin omega t. Then plus b can be d sin phi cos omega t. You can take this as cos a sin b plus sin a cos b. Like a way you can take. What is cos a sin b plus sin a cos b? Cos a plus b, right? So we are going to write like this. What is it actually? F of t can be written as d is taken outside. Okay. So this cos A cos B formula we can apply, and then it will be cos of phi plus omega t. Okay. So d cos, sorry, d sine. Okay. It is a sine. So it is the formula for sine. So sine A plus B. So it will be d sine phi plus omega t. So d sine phi plus omega t or d sine omega t plus phi, whatever it might be, we can write. Okay. So what is d now? D is the amplitude, magnitude of an amplitude, both the magnitude. So if you are taking a square, root of a square plus b square will be d. What is phi? Phi can be taken from this. A by b is equal to d cos phi by d sin phi. Okay, if d gets cancelled, then you'll be having cos by sine. What is cos by sine? Cos by sine is 1 by tan. And then, so we are going to take This is 1 by tan, right? So tan phi. If you reciprocate this, then that will be tan phi. What is phi now? You can bring this tan here. So tan inverse of V by. So this is phi. Okay. So any periodic function. So Jean Joseph Fourier. Fourier was the famous French mathematician. He proved any periodic function can be expressed as a superposition of sine and cosine functions of different time periods with suitable coefficients. Okay, from this mathematical assumptions, we are going to talk about simple harmonic motions. Okay, so we are going to see that one in the next video. So until this, you can go through it. So here you are given following functions of time represent periodic and non-periodic motion. Given which one is periodic motion, you are going to write like that. Okay, which of the following functions is periodic or non-periodic, or give the period of each case of periodic motion. So omega is any positive constant it is given. If it is sine omega t and plus cos omega t, definitely it is a periodic function. It can also be written as like this. From this, you can follow. What is d? D sine omega t plus phi we can take. Okay, that phi can be taken as pi by 4 here. Okay, and then what is d? D can be written as because which of the following functions it is given. So omega is any positive constant they gave. Okay. Okay. So it can be written as D can be written as um so here A is 1, B is 1, right? So D can be root of A square plus B square. So that is equal to 1 square plus 1 square, that is equal to root 2. So this is root 2. Okay. What is phi? Phi can be taken as tan inverse of B by A. B by A means B also 1, A also 1. So tan inverse of 1. So when tan becomes 145 degree, that is equal to pi by 4. So phi is equal to pi by 4, you have to replace this. So this is the famous formula. So like a way only you have to find this. You will not be given in your book, okay, how it comes. How root 2 comes, how pi by 4 comes, it's not given. We are going to use these formula to find this takedown. Okay. I hope it is clear for you. Then, so what about the second period? It is an example of a periodic motion. It is given. Yeah, sine omega t plus cos 2 omega t plus sine 4 omega t it is given. Okay. So it can be noted that each term represents a periodic function with a different angular frequency. Got it? So each and everything, omega t is one, 2 omega t is another one. So see, if you listen properly, so omega t, 2 omega t, 4 omega t. So different angular frequency it is given different. I mean, since period is the least interval of time after which a function repeats its value. Sine omega t has the period of 2 pi by omega. Sine cos 2 omega t has a period of pi by omega because 2 gets cancelled, right? Okay, because it is given 2 omega t. Okay. That is equal to T naught by 4. Pi by omega will be T naught by 2 and the 2 pi by 4 omega will be T naught by 4. How it comes, how it can be achieved. What is T naught here? T naught has the uh, time period. It is the sine omega t's time period. Okay, 2 pi by omega, we know that, right? If it is cos 2 omega t, then it will be 2 pi by 2 omega. So 2 gets cancelled. So pi by omega. Pi by omega is half of T naught. Okay. Then if it is sine 4 omega t, then that is equal to 2 pi by 4 omega. So it will be pi by 2 omega. Okay. Pi by 2 omega means again it is reduced to half. So it is T naught by 4. So the period of the first term is a multiple of the periods of the last two terms. Like that it will be going. So the sum is the periodic function. it is the it repeats in T naught, right? First one is T naught, second one is half T naught, third one is 1 by 4 T naught. Like that, it is repeating. Okay. So it is a periodic function with a period 2 pi by omega. This is very important. You should understand. And then what else? Next one, the function e power minus omega t. It is not periodic because it monotonically decreases. Okay, with increasing time period. So it's function like this. If t is tends to infinity, until t tends to infinity, we can make, if t tends to infinity, then exponential will be zero. Okay. So like a way it is, so it's not periodic. Then log omega t also increases monotonically with time. So it is also not periodic. Okay. So e power minus omega t log omega t is not periodic. Keep in your mind, e power and log will be the reciprocate functions. If exponential increasing, then log will be decreasing. If the exponential decreasing, then the log will be increasing. Like a way. So depends upon the negative and positive of the matter. That is also considered. Okay. So take down all these things. This until this example we saw. In the next video lesson, we are going to see simple harmonic motion. Thank you.